Hey guys, so this is 13.3 and I know I'm gone and I didn't expect to be. They moved a track meet on me, so I'm going to try to walk you through everything you need to know to be able to be successful with this assignment. It is a worksheet that you're doing, not a textbook assignment, but I am going to use the textbook to kind of guide you through some of the work. Now, the first thing that we need to be able to work through is understanding this one specific adjustment or small adjustment. It's really not a huge adjustment, but we're going to redefine sine, which we always called it opposite over hypotenuse. Well, the problem is if my angle is not an acute angle, meaning I've got an angle, say my theta is 100 degrees, like maybe in this picture is 130 degrees. Okay, if theta is that big, it doesn't fit in a right triangle, which means I can't say the opposite and the hypotenuse. If I drew a triangle right here, okay, this triangle right here is not a right triangle. It doesn't work. But if I change my approach a little bit and I think about the triangle here that's created on the back side, okay, then there is a right triangle. And all of these angles should be able to produce something like a right triangle. But we want to redefine it so that we're not talking about opposite and hypotenuse and things like that. If I were to talk about, let's zoom in here a little bit so we can see a little closer here on this picture. Okay. If I were to talk about this triangle right here, over here on my graph, this side that goes up and down, okay, what we're going to do is we're going to consider this to be our theta right here, okay, and if we consider this little angle against the x-axis to be our theta, then the opposite side will always be the length. How long is it? It'll be the length that is equivalent to whatever our y value is for this point. So if I know where this point is, say it was 3, 4, then the opposite side over here would be 4 units long, because that's how tall the triangle is right there. So it turns out that the opposite side can be defined by a y value. So we can use y instead of o. And the hypotenuse of the triangle, my hypotenuse right here that I'm drawing in, that hypotenuse is also the radius of the circle that this line is sitting on. So if you look at where my line goes through and there's a dot on that circle, that the hypotenuse will be equivalent to the radius of the circle. So if you know that you have the y value and you know the radius of your circle, you have the sign, not as O over H, but as y over r. Similarly with cosine, cosine is the adjacent side over the hypotenuse. If I come down here and talk about this adjacent side, I guess this point would have been -3, 4. But then if I ask, well, how long is this side? Well, this side is the length of the x value, which will be a -3. Now you might say, Mr. Welch, how can you have a -3 length? When we start to talk about these rays, or these rotation angles, these angles of rotation with this ray that extends off of it, we're actually dabbling with an idea that we use in physics called a vector. And vectors have direction. And so for our purposes, we are definitely going to include the direction, which is to the left. So it turns out that the adjacent side can be replaced with the x-coordinate, just like the radius can be replaced with the hypotenuse. So literally, if we'll just go through our normal sine cosine tangent, if you just let O become y, A become x, and h become the radius, then you're good to go. Now on the first 4 problems of your assignment today, let's jump over and grab a blank page. On the first 4 problems of your assignment today, what you're going to see is problems like this. where you will be given a rotation angle. Let's take question number 1. Okay. You have a rotation angle and a point. All right, so you're told that you're using the point 3, 6, and you're just told we're rotating this way. Okay, so what we're going to do is we're going to create a right triangle by going straight down and straight over. Okay, and we can come right back up. Boom, there's my right triangle. And this angle here in the corner against the origin is always going to be where we put our reference angle, our theta. Okay, our theta has to be touching the x-axis. It'll never be up here. It's always a straight back to the x-axis triangle. Okay, so it should be in this kind of position. It could also be in this position, that triangle. It could be this position. So it's always against the x-axis, right? And here's my x-axis. Always against the x-axis. Okay, so now we have some information. We know that the x-coordinate, which is the adjacent side, is 3. The y-coordinate, which is the opposite side, is 6. But I don't know the radius. To find the radius, I will have to use Pythagorean's theorem. And because that's the hypotenuse of the triangle, it's just simply 3 squared plus 6 squared equals that radius squared. You can use c squared if you want. We're using Pythagorean's theorem. That's fine. 3 squared is 9, 6 squared is 36. Add those together, we get 45 equals r squared. And here we'll take a square root to figure out what the actual radius is. R is now the square root of 45. Now, I'm not going to come after you real strong on reducing this root, but it is something that we should look at doing. And so if we were to simplify this, okay, we would remember our rules. Let's say we take the square root and we split it. But when we split it, we have to have a perfect square root. And 45 divides by 9, which has a square root. And over here, our leftover would be 5. 9 and 5. Well, the square root of 9 we know is 3, and our leftover root 5. So our radius is actually 3 root 5. Now, in the worksheet on number 1, it specifically asks us to find the sine of theta. Well, the sine, we always used to define it as O over H. We've expanded that a little bit to include the idea of y over r. The opposite is the same as the y value. The hypotenuse is the same as the radius of the circle. Now, guys, if we're honest, okay, even with the circle there, you can still choose to come back in and just focus on the triangle only. If you just look at the triangle, you can say, well, 2 or 6 is my opposite side, 3 is my adjacent side. You can still live with those old definitions. You just have to understand that we're going to start branching out a little bit. And there's a big reason for that we'll talk about towards the end of the assignment, or after this question. So my y value, or my opposite side, was 6, and it's over the radius of 3 root 5. Now, first things first, this does reduce. 6 over 3 reduces to 2 over root 5. Think about the 6 and the 3 reducing. Ignore the root 5 for a second. You end up with this. But we learned last time we're not supposed to leave roots in the bottom. So we times by that root, and we end up with 2 root 5 over 5. And there's our value of sine. Okay? You'll get different definitions: sine, cosecant, cosine, tangent, and you just need to be comfortable with going through those different options. Okay, now comes the big payoff. You guys will need to get your unit circle out. That piece of paper that needs to be passed out with the worksheet. Okay, so you have your worksheet, you have your unit circle. On your unit circle, you will need to record the following information. Now, I'm going to put it up. You're going to need to record all of the information that is on this screen. Okay? In the unit circle page that you have, there is a spot for you to label the degrees, okay, which go on the inside edge. You can see the degree mark on your paper. The next blank space, you'll need to put the radian version. These are all fractions except for pi and 0. But you can see that we have all of these radian measures. Each one of them goes on one of these lines. We will talk about this when I'm in class with you, because eventually you're going to memorize this whole thing. So there's our radians. There's our degrees. Do make sure you start at 0, right? Now, on the page that you have, there are actually 2 spots down here to label. So let's go ahead and talk about what should be on these labels. There's 2 lines. There's a line here and a line here. A line here and a line here. Obviously, they both start at 0. 0 radians, 0 degrees. If I made a complete circle, where would I end up at? 360 degrees, which is equivalent to 2 pi. Okay, so at this point, you might need to pause the video in just a second and get everybody to record this information down, because without this information, you can't finish the worksheet. Now, keep in mind, I'm going to zoom in here a little bit. The way that these are done, okay, they are fractions, root 3 over 2, negative 1 over 2. There is a very specific pattern that we're going to talk about again when I'm in class and we can do question and answer sections, but for today you just want to make sure you have them all written down exactly correctly. There's one other thing you'll want to add to the middle of your page. If you are using the unit circle values, okay, if you're using these values, there's one other piece of information that is guaranteed to be true. The radius on this circle is 1. That's how all these ordered pairs are defined. Okay? And so it's important that you understand that the radius in this entire circle is 1 everywhere you go. Let me zoom back out and clear up. Okay, so again, pause, record everything that you need to, and then when everybody's ready to go, we can get back to going. Okay, so pause video. Okay, so assuming that you got that all recorded down and you understand what those are, they're sitting in front of you. Okay, first thing you need to understand before we can move forward is that every one of these dots has an ordered pair with an x and a y. And of course we know that the radius in this circle is 1. So when I ask you to find the exact value on 5 through the end of the assignment, number 20, of something like the tangent of negative 60. Let's do that one. This is question number 20. Let's just do number 20. It says, find me the tangent of negative 60 degrees. The first thing I want to do is I want to go and find that on my circle. So I'm going to go to negative 60 degrees. Well, 60 degrees is that way if it's positive, and this way if it's negative. So because it's negative, I'm going to come down, and I think, okay, I start at 360 and I'm going backwards. So that should put me right here at 300. What I'm really after is the ordered pair 1/2 and negative root 3 over 2. That's the information I want to have. If we go back to our definitions of tangent, we always called it opposite over adjacent. But we know that now we can call the opposite the y value and the adjacent the x value. So the tangent of negative 60 is the y value right here divided by the x value right here. Or I could write negative root 3 over 2 over 1 over 2. So I'm literally taking my y value over my x value at negative 60 degrees. And now I just need to clean it up. When we have a fraction over fraction, we keep switch flip. So this is the same as negative root 3 over 2 times 2 over 1. Right? Instead of division, we switch to multiply, and then we flip. Here the 2 is going to cancel the 2, and the answer is negative root 3 over 1. Do I really need a denominator 1? The answer is no. So my answer, negative root 3. Now, here's what's cool. Well, everybody has a different definition of cool, but here's something that's really interesting. If you were to take your calculator out, make sure that you're in degree mode, because that was a degree problem, 60 degrees. And if I were to take the tangent of negative 60 I get negative 1.732050808, and it goes on from there. Well, what is that number? Well, if I take negative square root of 3, which I say is my answer, sure enough, that's exactly right. So using this unit circle is going to allow us to find exact answers for a lot of different values. Okay, not every value, but all the values that exist on this sheet, they are things that we can calculate. Let's look at just one more, and then honestly, guys, you just need to fumble your way through it a little bit. There's no perfect sunshine or no perfect situation, but let's take a look at number 10. Let's go, yeah, 10 will be black, that's fine. All right, on number 10, we're doing the cosine of negative 315. Okay, so first question is, where the heck is negative 315 on this grid or on this page? So first, we got to recognize that we're going backwards. Okay, and so if I go backwards, because I'm going negative, this would be negative 180 degrees. And you got to use a little bit of logic here. This would be negative 270, right? Because I'm going 90 more. Okay, so 270, 315. You know, I'm just thinking 315 minus 270, that's 45 degrees more. So I'd go another 45 degrees, which would put me right here at 45 degrees. Now, if you're really struggling with things like negative angles, a really simple way to fix them is to simply add 360 degrees. Because 360 degrees is a full circle, it'll just take me backwards the other way as a full circle. Turns out this is 45 degrees. So all I'm going to do is come and grab this ordered pair here, and then I go work with my cosine rule. Cosine we always defined as A over H, but now instead of adjacent, we said we'd switch that to X. Instead of H, we said we'd switch it to R. Now, the cosine and the sine are actually very cool problems because of what happens here. The X value, this guy right here, root 2 over 2. That's my X. What's my R? Well, we said when I was asking you to write all this stuff down that the radius on the circle is always 1, which means that dividing by that 1 does nothing to the problem. It turns out in a very simple way that when we use the unit circle values, meaning these ordered pairs that are here, we can actually simplify the sine formula. It's not the y over r. It's the y over r, but r is always 1, so the sine is really just the y coordinate. And coincidentally, or along with that, the cosine is always x over r, but if r is always 1, then it's just x. Cosine is the x coordinate. So if I asked you to tell me the cosine of 120, you could come and say it's negative 1/2, and you wouldn't ever have to make a calculation. Similarly, if I asked for the sine of 135, you'd come find the y value and say it's root 2 over 2. So when we're doing sine and cosine from the unit circle, we just get to take the x or the y value. Now, I'll be honest, I know that when we do this kind of work, we're introducing new stuff and I'm not here. It's a real challenge. But what I will say is that if you'll work together, look at some of the notes in the textbook, maybe even go back to 13.3 and watch the instructional video. It'll go back through and go through another example of it, try to walk you through things. You can also, I don't know if this one has a homework help video as well. It might not. Yeah, it seems like it doesn't. So if you go back and watch the notes video for 13.3, the regular one out of the textbook, maybe that helps fill in some gaps. But best thing I can do is tell you that you want to become more comfortable with what's here. Okay? All right, bring your questions. Shoot me an email if you're stuck on a specific type of problem. I'll be happy to answer it over the weekend, but let me know what I can do to help you. All right, good luck, guys.